Nope, looks like we're live. Let me make sure everything's working. I think we're live and good to go. All right. So welcome to Loft version 3 live stream. So we're going to be talking about Loft today and the new release. We're going to show off the new UI. We're going to demo a few of the new features. And I'll go ahead and introduce our guests now. So we have Fabian Krom, CTO of Loft, and then Carl Montanari, software developer at Loft. And then I'm Mike Peterson, tech marketing, started recently. But today what we'll do is we'll show you a couple of demos. And if you have any questions or if you want to see us show anything else off with the new UI, just let us know. So I guess with that, pretty quick introduction. Let's get Fabian to introduce himself first, and then we'll get Carl to introduce himself, and then we'll move on. So how's it going, Fabian?
Great, I'm good. Hey, yeah, my name is Fabian. I'm the CTO and co-founder of Loft Labs, and yeah, nice to meet you. Everything. We are pretty proud to show version 3 today on all the new exciting features. And yeah, with that, I'm handing over to Carl.
Yeah, right on. Yeah, I'm Carl Montanari. Pretty pumped for version 3 since I came on, and that's all I've been working on since I started here at Loft, however long that's been. So yeah, looking forward to sharing some of the stuff that we've been up to.
Awesome. Let's get into a demo. And like I asked for names too, and I just messed your name up like immediately. Sorry. All right, okay. So you share screen, and I'll show it off.
All right, perfect.
All right, let's add it. There we go.
All right, so this is the new version 3 Loft UI. So we changed a couple of things around. If you have seen version 2 already, you probably noticed the main difference is the new menu we have here that has a sub menu here. And we also changed a couple of concepts around. So before version 3, we had cluster access objects that essentially allowed you to define access to clusters. With version 3, we have a new concept called projects. And projects is essentially a sort of container for different virtual clusters and spaces that share a common configuration through project settings. So in the project settings, you can assign members, you can assign clusters. This project is essentially allowed to use. You can assign virtual cluster templates or space templates, which essentially can be used within the project, which makes things a lot easier in terms of managing access to clusters, because these are now done through projects instead of cluster access resources, how it was before. In general, so what is Loft mainly about? So one of the most prominent features in Loft itself are virtual clusters. Virtual clusters are essentially Kubernetes clusters, regular Kubernetes clusters that run in other Kubernetes clusters. And Loft essentially is the manager to create and manage those virtual clusters. So let's go ahead and create such a virtual cluster. I already have a local Kubernetes cluster connected, since virtual clusters, similar to virtual machines, need an actual machine or physical cluster to be created in. In this case, I just used the local cluster where the Loft instance is running in. And in the default project, I can now create a new virtual cluster.
So for people that are new to this, why would you create a virtual cluster? Like, what would you use it for?
Yeah, that's a good question. So in general, there are a couple of benefits virtual clusters have, which are similar if you would think about like virtual machines and physical machines. So a virtual cluster allows you to essentially create deploy every application into it, regardless of it being an operator or any application that needs more access than a regular namespace would give you. So virtual cluster is really about kind of like encapsulating all resources and making sure these stay separate from the rest of the physical Kubernetes cluster. So this is really a prominent use case. We always refer to virtual clusters as namespaces with superpowers because they allow you to be cluster admin essentially within their virtual cluster without having any bad effects on other applications that run on the physical host cluster. And besides
I'd like to.
Sorry, yeah.
Yeah, I was just say one thing that I always love when we talk about virtual clusters. It's like super useful and important for me. Is that if you screw up in a virtual cluster, you could just wipe it away, and then it's like nothing ever happened. So you don't leave any kind of cruft running in the host cluster, the parent cluster, whatever you want to call it. But I think that is an undervalued or underappreciated aspect of virtual clusters for sure.
Definitely. And besides that, you can always create a virtual cluster in seconds. It's a lot cheaper. So compared to a physical cluster, virtual cluster workloads run on the underlying host cluster. So they're much more resource efficient because you don't need to reserve any virtual machines just for your virtual cluster. Rather, Kubernetes itself schedules all workloads within a virtual cluster. So usually a virtual cluster is a lot cheaper than spinning up separate physical clusters. So the main use case I would say for virtual clusters is to reduce cluster sprawl and to save costs ultimately by consolidating on a couple of physical clusters instead of creating a separate physical cluster for every task. All right, let's go ahead and create such a virtual cluster. So what we see now is this new virtual cluster gets provisioned in the underlying local cluster. And I'm the owner of this cluster because I've provisioned this. It has a name. It's right now pending. And now we already see it was created only a couple of seconds ago, and it's already ready. We can now go into that virtual cluster and see namespaces in here. And the cool thing about virtual clusters, as I said, is they are completely separate from the host cluster. So that means if I create a new namespace in here, this namespace will only stay in the virtual cluster and not be propagated to the host cluster. So let's try this real quick, create an example namespace in this virtual cluster, and inside this virtual cluster and inside this namespace, also create an example. So this is now scheduled. And what we see when we now go back to the virtual cluster, we can go to the actual host namespace where this virtual cluster is running in. And we see this is now the host cluster where this virtual cluster is running in. And we see this pod is now, even though it's in a separate namespace, running inside the namespace of the virtual cluster. And if we go to the host cluster and check the namespaces that exist, we see there is no example namespace which we have just created because that namespace purely lives in the virtual cluster. So when I go back into the virtual cluster, I see, oh, my example namespace is there again. And I also see the example pod being in the correct namespace. And this is really something that can be very valuable because now this also means we can essentially install every application that usually requires like more access than a regular namespace would provide you. So for example, we could create Argo CD, which gives you or installs essentially custom resource definitions. It needs cluster roles. It needs all sorts of permissions on the cluster. And usually, if you just have access to a regular namespace, this is not possible to install. Or if so, you wouldn't be able to install, for example, multiple versions of Argo CD because they would collide with each other. But here in a virtual cluster, you can install Argo CD. you see Argo CD is now deployed. The pods essentially are running. You can also check the custom resource definitions of Argo CD. They are deployed as well. So you see the app projects, applications, application sets of Argo CD that was deployed successfully in the virtual cluster. And in the host cluster, if you check the resources, you will see, hey, there is no Argo CD resources at all because they purely live in the virtual clusters. So virtual clusters are definitely a powerful tool to separate your applications from each other and make sure you have kind of a sandboxed environment for your developers or even your production systems.
Looks like the UI does a good job letting you dig into. I have a question about virtual clusters. So everyone's getting excited about like ephemeral clusters, right? So this is perfect for that. But some people are saying, I've heard before, this isn't like for production. Like you don't want to use this for production. You're just using this for dev. Are there any use cases where you would use this for production, or is this mostly focused on like developers and your dev environments?
Yeah, that's a good question. So in general, the important concept about virtual clusters is that they are not a workload virtualization and rather a control plane virtualization. This means that only the control plane, the Kubernetes control plane, is virtualized, but the actual workloads running within the virtual cluster, like you see here, these Argo CD pods, essentially, they are copied over to the actual host cluster. So you see when you go inside the namespace of the virtual cluster, you see they are also running on the host cluster, which means that a problematic workload that kind of escalates privileges or tries to do things in the cluster an application shouldn't do, would still be able to do that even in a virtual cluster if you don't take any extra security measures. And that is kind of, I would say, the biggest problem for virtual clusters right now. But we have a mode in virtual cluster that's called isolated mode, and I have created a template for that. So it's called isolated virtual clusters. And essentially what this does is it creates Kubernetes resources alongside the virtual cluster, so a resource quota, a network policy, and a limit range, and so on, and also makes sure privileged pods cannot be created on the host cluster itself. But for actual production use cases, you probably also want to take additional security measures like sandboxed container runtimes or node selectors, so that you divide your virtual clusters also, or you schedule your virtual clusters also on separate node groups. But in general, virtual clusters, can be used for production use cases as well. But in our opinion, dev and testing use cases are the best fit for now. But we see more and more customers also using virtual clusters for production use cases.
Yeah,
and it should inherit your. Sorry, go ahead.
I was going to say, probably worth also adding that K3S and Kate's actual upstream Kate's distros can be ran in HA mode. So again, that's like the control plane, but obviously you still want that, highly available if you're talking about a production kind of workload. So you could do that and use external data store and all sorts of things to make it more robust and highly available. So definitely valid use cases for production stuff.
Exactly.
And if you put a lot of work into securing your base cluster, it's just going to inherit the security, it sounds like, right? So
exactly, yeah. So it's also kind of the requirement that you make sure. So the isolated mode in vCluster already pre-configures as much as it's possible with like vanilla Kubernetes resources. But there is a couple of things such as like these container runtimes that you could use a more hardened one like Kata containers, or there are some other container runtimes as well that make sure it's not as easy to break out of container anymore as with maybe the default runtime. So we definitely recommend things like that for production clusters to harden security. But if your cluster is already using such things, yeah, virtual cluster inherit that automatically.
Awesome. Is that the demo? That's the demo. It was pretty good.
There's one more feature I would like
Okay.
to show, which is actually something we've added in version 3 as well, which are templates and template versions especially. So as I showed, I have a pre-configured template that's called isolated virtual clusters. And usually the more virtual clusters you have, the less time you want to spend on configuring them individually. So what you would do instead is use a template. In our case, we used this template. And then creation is a lot simpler because you essentially configure everything on the template and then create the virtual cluster with that template. And we will do that now. So we see here, we have an assigned template now. It's running again in our local cluster, this time with a little bit a different name. And one new cool feature we've added with version 3 are actually template versions. So this is actually not the latest version here. The latest version is 0.14.2. So what we will do now is create a new template version that we will call 0.14.2. We can change the virtual cluster version here as well. We update the template. We see there's a new version now. The previous version is defaulted to 0.0.0. And we'll see that, hey, our template now is outdated. And we can, with a single click, update it to the latest version. This will take a second. And then, the virtual cluster is restarted and redeployed with this new 0.14.2 virtual cluster version. And this makes it a lot easier to make sure only like part of the virtual clusters are updated, or you can also roll back virtual clusters now to like a previous template version. So this template versions essentially give you a lot more control over how you want to manage your templates and on which essentially virtual clusters you want to apply the new changes in the template.
That's awesome. And then there's ways to automate that, which is what we'll talk about next. Right,
that and also template parameters are another really cool feature too. We won't talk about too much now, but another cool way to make those templates and have most of it pre-canned, but still let your users have, some flexibility within the constraints that you want to provide as like the administrator too. So that's always super handy.
Awesome. So we got Carl up next with another demo. What are you going to show off today? Argo CD and some other fun stuff.
Which, if I could figure out StreamYard, select window or screen. Yeah, that'd be great. Screen. I don't know which screen is which. We're gonna just Russian roulette here with the screen. Oh, no, not that one. Oh, maybe. I don't know. It doesn't show a thumbnail of what's on the screen. So how about that one?
All right, hold on. That one's just your desktop.
Okay. All right. How about this? There a window on it now? I only have 3 desktops, so I don't know.
I'm gonna add it
one.
to stream. You see it? It's this one.
Oh god, they all look like that. What's going on? Share screen.
Thanks, Fabian, for the demo too. That was awesome. Like,
yeah, sure. With the new version 3, we also. Okay, now it's.
Oh, still. I see my mouse and I don't see iTerm. That's right there. I don't know what to do about that there. That's not ideal.
Can you share a desktop and then drop those in, or is that? That's
yeah. I mean, yeah. So I'm like,
all right, let's try this one.
Stop screen, share screen. I swear I've screen shared before. Okay, how about an app? We can do that. Maybe. Maybe. Well, this is not going to plan here, it seems.
That's how demos work when it's live.
Yeah, right. The demo, I swear, works, but let's see.
I'll talk about what you're going to show off. So Carl's going to show off Argo CD and the Argo CD integrations and stuff once we get that up there. And then that'll be, okay. So Fabian, how would you use Argo CD with what you just showed us before without going in too deep into what Carl's going to show? Would you be, creating V clusters in the UI? Like, who does that? Maybe if you have a small team, you've got like one admin going in and doing that. But if you have like a larger team, you're probably like creating stuff in Argo or are using the API and creating stuff and maintaining it somewhere else.
Yeah, I mean, there are multiple ways how you could incorporate Argo CD essentially into this. So a way which we often saw, which Carl will also show, is essentially that you create virtual clusters and then want to connect these virtual clusters to Loft, to Argo CD, which is pretty cool because you can then just use these virtual clusters the same way as you would with regular physical clusters, and you could test, for example, CI/CD runs. You can give pre-install applications for these virtual clusters with Argo CD. And since Argo CD has a pretty neat suite of automation tooling, such as application sets, you can fully automate this with the new Loft features. So as soon as you create like a Loft virtual cluster, it's automatically connected to Argo CD. An application set within Argo CD sees, oh, there's a new cluster connected, and deploys an application to that. So yeah, with our new Argo CD feature, it's essentially possible to fully automate this process.
So like Loft's just a CRD, right? Like it's something. So all of the resources that I want to create and make everything, those are defined somewhere to where I can just create like a Kubernetes resource for the most part, right?
So in Loft, everything is a custom resource definition, which means you can automate things according to regular Kubernetes API requests, where like a lot of tooling is out there. You can use Argo CD essentially yourself to manage other Argo CD virtual clusters, and even Loft itself. We've done some effort now that you can manage Loft itself with Argo CD a lot more easily. And you can also use other tools such as Helm or kubectl or customize to manage Loft resources. Like any other Kubernetes API.
See if this one pulls up. Oh,
all right.
I see something. And so like that's some of the use cases you see, right? Like whereas these ephemeral clusters are great for something like Argo CD. Like if you want to just like spin up a new cluster and then pull a PR and test it or do something like that.
Yes, exactly. Yeah. Okay. So, I mean, like really the biggest benefits of virtual clusters is like the speed you can spin up a new one. They literally start in seconds. And essentially the encapsulation of what's inside a virtual cluster. So that means if you want to have like a thermal environment where you want to test out things really quick, you create a new virtual cluster, deploy something in it, and then destroy it afterwards, and everything is gone again. So this is really cool for like these quick and dirty testing or development tasks.
So no longer say no to your developers when they say, can I have a cluster?
Exactly.
It's like Carl's ready.
Oh my gosh. Good job stalling, y'all. Except now I have like lovely audio. Can you admit imposter Carl so I can leave on this browser?
Yeah.
Is that okay? There we go. How about now?
Yeah, we can hear you. Sound good.
Oh, look at that. Okay, yeah, sorry about that. Good job stalling, y'all. That was really appreciated. Apparently Firefox just didn't want to cooperate, so off to Chrome we go. Well, that was a bummer. Fabian stole all my thunder now, talking about Argo and stuff. But yeah, so we're just going to do another demo here. Some of the Argo stuff that obviously the guys were talking about, and kind of show stuff also from just applying some manifests and stuff. So I know y'all were talking about everything in Loft is just CRDs. Everything's like a Kubernetes native, first class, whatever you want to call it, look and feel. So we're going to actually use the UI to kind of inspect what's going on, but everything we're going to do in the demo here, we're just going to do with a little demo script that I got, so I don't have to type and try to talk at the same time because I'm not very good at that. So to set the stage here, we've got obviously the Loft running here. We've got 3 clusters actually connected to Loft. So the local cluster, that's the cluster that Loft is running in. And then I've got 2 other clusters, which are actually lies. They're actually virtual clusters, but we're treating them as real physical clusters for purposes of the demo. And then otherwise, we really have nothing. This is like a brand new Loft installation, so nothing at all kind of happening. And what we want to do here is we'll use this lovely little demo magic script here. And we're going to go ahead and bootstrap a project here. Real simple. There's two manifests here, or 2 YAML documents in this project.yaml file. The first one is the project itself. So now we have a lovely Acme team project, fun little name. And we also created a service Taco Cat vCluster template. So the template we don't really need to do. Fabian already demoed, kind of the main things with this. In my case, I just run K0S because it plays nice with my home lab NFS setup. So that's nice and fun. And then we've got this Acme team project. The project is really like the fundamental kind of building block for Loft 3. Everything kind of builds around the project. It's where you apply your policies and really the main organizational kind of unit. So I've created this for Acme team, as we can see here. You could do this per team or per project, like software project, or per like division, business division, or something like that. Obviously, your mileage may vary, and kind of there's no one best answer for this. But in this demo case, we're just going to say, hey, Acme team, and we've got this vCluster template service Taco Cat. So now we can go ahead and say, great, let's go ahead and create a virtual cluster instance. Got a new developer coming online. They want to have a dev environment spun up, or a safe place where they could do cluster-wide things like we were talking about. So I've got this virtual cluster coming online here. One other thing I didn't mention here is that at the project level, we've enabled integration to Argo CD. So I actually had Argo CD already deployed in this example. And actually Argo CD deployed Loft in this example, and all of this is running in a vCluster. So we're kind of dogfooding this at every level here. But yeah, for this project, so per project, you can integrate or associate the projects with an Argo instance. So in my local cluster in the Argo CD namespace, I'm running Argo. It's available here at this argo.dev.home URL, and we've enabled SSO integration. And once we do that, we get this cool little not lookup open, but we get this cool little Argo box. I've already logged in, obviously. so we can just go ahead and pop over to Argo and see this is actually the Loft instance and the 2 agents that we're managing in the connected clusters.
So if people are interested too, we can provide examples for this. Like if you want to like run through this demo on your own, like we can end up providing that eventually too. And projects are new, right? So we don't know how our customers and stuff are going to use them necessarily, like how they're going to section stuff off. So we have ideas, and you can read our docs about that. But if you have interesting use cases for projects and how you're using them, let us know, like on Slack or something like that. We're interested.
Yeah, definitely. It'll definitely be an organic thing growing over time and all of that. But yeah, so we've integrated this project with Argo. And then the virtual cluster that we created, the virtual cluster template also had basically a checkbox that says, hey, when this virtual cluster gets created, go ahead and add me to Argo. It's grayed out here because it's managed by the template in this case. But if you created it without the template, you could slide the slider around. If we wanted to change that, we would just modify things in the template. And then from an Argo perspective, we can go ahead and we can look at clusters, and we can see there's nothing running in it yet, so it wants to be unknown. But we can see that the cluster has already shown up in Argo. I didn't do anything, like this just magically happened. It wasn't there before. So that's pretty cool. And then similarly, if we deleted this vCluster, it automatically gets cleaned up from Argo, and that's something that we're handling in the controller on our end. So just makes your life a little bit easier.
So here's a question for both of you. Like why Argo instead of Flux? Is there an opinion? Is Flux something we're thinking about in the future?
That's a Fabian question.
Yeah, I mean, yeah. So right now we started with Argo CD because the integration was actually a little bit easier for us to do. and we saw a lot of traction on the Argo CD side. Especially like the integration with the web UI was pretty neat, and we thought like, hey, this has a really big value that we can provide there. But yeah, in general, we also think about doing a Flux integration. I wouldn't say this is off the table at all. It's more something we probably plan to do in a later release. We wanted to start with Argo CD first. And then we get a feedback for this, and then if enough interest is out there to do a Flux integration as well, we'll definitely add that in one of the next versions.
Awesome. Sorry to interrupt, Carl.
No, it's cool. I hear myself getting committed to creating new features. So live on the stream. No, that's all right. So yeah, anyway, now we've got kind of moving on. We go ahead and create this demo app repo. This is just a very, very silly repo. So we just created that in Argo. So now that we can use that app to deploy things into our virtual cluster, basically that's all we're doing there. And then all I have to do is type enter, and I can't even do that. And then some cute set stuff here. Nothing really fancy going on here. All we're doing is creating an application, an Argo application. And we're saying, hey, this is in the vCluster or the service TacoCat dev1 vCluster. And we want to create an application called that exactly. So now we can go ahead and say, hey, great, it's already synced. Again, Argo already is aware of the vCluster because when we created the virtual cluster, we had that box ticked. It's already added there. Everything's looking good. We can go ahead and look into our vCluster, and we can see this is just a silly demo app. All it does is deploy an Nginx pod, so not too exciting. But we can see, hey, it's already up and running. And then you get all the normal Argo things that we don't need to get into here, but all the self-healing and update the thing in the Git repo, automatically push to the vCluster, yada yada yada, all that good stuff. So then we could say, great, this is pretty cool, but now that we've got our application running, we actually want to put some quotas on this project. And this is one of the things that I think is really, really cool about the projects. Let me refresh this real quick. Is that we can enforce quotas at a project level. So like in normal Kubernetes things, we could say, hey, we could have a resource limit on a namespace, whatever, all pretty easy. What's really interesting, though, is that we can have quotas applied to projects, and projects can span not just multiple namespaces, but multiple clusters and virtual clusters. So we get a really kind of powerful kind of point to manage this kind of thing. So we just went ahead and set this simple quota for pods, no big deal. And we set it to 5. We know that we've got 3 pods running right now. So that's the virtual cluster pod itself, core DNS running in the virtual cluster, and then our silly little Nginx demo app. And now we can go back to our terminal and we say, great, we've got another developer coming. They want to work on the same thing. Let's create another virtual cluster. So, okay, cool. We can go back. We can create the virtual cluster, just a quick second here. It'll go ahead and do its thing. We can go ahead and look at our project quotas and maybe refresh this just to give it a little helping hand. And we can see, hey, great, we've already come up to 4, and we should go up to 5 here once core DNS is actually deployed. And we can see, obviously, this is happening, real time. Everything's good. What I didn't say is that I also deployed this second virtual cluster into a second physical cluster. It's a bit of a lie. It's an actual virtual cluster, but from the purposes of the demo, it looks and feels like a physical cluster. So now that quota is actually spanning both of these clusters, which is really quite powerful, I think. And then we can go ahead and say, great, let's do the same thing. Same developer wants to deploy the app into their virtual cluster, do the same stuff with Argo. Go ahead and we see, okay, great. The app's going to get deployed, or it's going to try to get deployed. But by the time that core DNS pod came up, we will not be able to deploy this Nginx because we'll have exceeded our quotas, right? Because we had the 2 vClusters plus core DNS in each of them, plus Nginx in the first one. And that gets us to the total quota of 5. Obviously, this last pod can't be scheduled because we're not allowing that.
So with planning cluster or planning quotas, you want to at least have 2 for each cluster that are saved?
Yeah. It depends on how you're running your vCluster, right? If you're running like an HA vCluster, obviously you need more pods. But yeah, maybe the pod example is pretty kind of like a toy demo example for things like this. Maybe you'd care more about like CPU or something like that. But yeah, obviously you'd want to account for that vCluster as you're running them in the projects, because obviously they're going to be real pods for the API server. It's got to live somewhere. So yeah, so that's it for the demo. Just a quick demo to kind of showcase obviously the Argo integration, automatically adding and removing. Actually, I guess we could go ahead and remove. If I can.
And there's a new quota too for active versus inactive clusters for like sleeping clusters, right? So you could template out a bunch of clusters if you wanted to and only allow them to run 5 at a time.
Yeah, that's actually a great point. So with vClusters, one of the values of vClusters is you can pause them, and then with Loft, you get a lot more kind of capabilities around that. We can put them to sleep. Effectively, what that means is we can scale all the replica sets down so that there's no pods actually running, right? And then we can apply quotas to virtual cluster instances in total, or virtual cluster instances that are active. So you could configure 100, I don't know, and you can say, I only want to have 5 of these active at any one time. We got 5 active. Somebody's got to go to sleep, so we can turn another one on, and you can do some kind of cool stuff like that.
Awesome. So that's our V3 live stream, pretty much just talking about all the new features and everything. Thank you both for the demos. They're great. If anyone missed it, like, it'll be on LinkedIn and YouTube later. You can rewatch it. If you have any questions, just post comments and stuff on there. But I'll go ahead and do our outro so we can head out. We actually hit a little bit more time than we were expecting, which is awesome. So here's my end of the stream stuff. If you want to get started with Loft, head over to loft.sh, and you can find more information about Loft, vCluster, DevSpace, and more. Join us on Slack, slack.loft.sh. Ask us questions, give us feedback. You can do that on GitHub too. And thanks for joining us today. So like I said, we just wanted to share some of the new features. You can check this out again on LinkedIn, YouTube, and I think the video is even on like Twitter, but I don't know. People are watching.
Don't trust this imposter Carl guy.
Yeah, I left it up because it's perfect. All right. Well, thank both of you so much. Thanks everyone for joining us. I don't know if you want to say anything, any parting words.
Yeah, at least for my demo, there's the whole kind of example of how to run or deploy and manage Loft via Argo is kind of what that demo is built on. And so that repo will be somewhere public on Loft. It's public on my GitHub right now, but it's kind of in an early stage. So we'll get that made official one of these days. So if you want to mess around with spinning up Loft, obviously you can do that with Argo. And then also the demo will be up there as well. So you can. Yeah,
I'll post on our YouTube video after it's moved over. So I don't have to put your GitHub on blast. Everyone, I'll put it there. Yeah. Fabian, you want to say anything?
So Loft is also free, so you can try it out up to, I think, 5 users for free. So give it a shot. Tell us how you liked it, and we are pretty happy to hear feedback soon.
Yep. All right. See everyone later. Thanks for joining us.
All right.
Yep.
Thank you.